Hello everyone, welcome to today's video presentation. In today's presentation, we are going to discuss about ionization process in dielectric materials. This is one of the important topic in electrical material science. So what is the learning outcome from this video? It will help us to understand the ionization process in dielectric materials, basically the primary and secondary ionization concepts. So let's begin. So what is basically an ionization process? Ionization is the process by which an atom or molecule acquires a negative or positive charge by gaining or losing electrons, often in conjunction with some other chemical changes. The resulting electrically charged atom or molecule is called an ion. Ionization process in gaseous dielectrics. Now, when this ionization comes in terms of a gaseous dielectric medium, what is happening? Gas in its normal state is almost a perfect insulator. This we know. Now, when a high voltage is applied between two electrodes that is immersed in a gaseous medium, it can turn our gaseous medium, which is insulator, into a conductor because of the dielectric breakdown that is happening within the gaseous medium. The process that is primarily responsible for the breakdown of this gas is termed as the primary ionization. This primary ionization will result into production of further electrons in the gaseous medium that will further ionize the gaseous medium and slowly will turn the entire neutral gaseous atom into ions. This process, where the primary ionization electrons result in the production of additional electrons and slowly completely ionizes the gaseous medium, is called the secondary ionization process. Now we'll in detail discuss about the concept of primary ionization. In a gaseous medium, when electrons are produced at the cathode, it is one of the electrode that we have placed in the gaseous medium by some external means. During its travel towards the anode, due to the applied field, it will make collisions with the neutral gaseous atoms or molecules, because the electron is passing through this gaseous medium, and it will result in liberation of electron and positive ion from this neutral gas atom. The liberated ions, they will further make collisions, and the process will keep on continuing till the electron reaches the anode. This is basically our primary ionization process, where an electron released from the cathode electrode will try to ionize the neutral gaseous atom that comes in its way while it travels from cathode to anode. And these neutral gaseous atoms get ionized into electrons and positive ions. These electrons and ions will help in the flow of current through this gaseous medium. Now, this primary ionization is basically happening by two ways. One, we can say, is by collision. The second is by photoionization. Now what are these two? Let's see. Ionization by collision, the process of liberating an electron from a gas molecule by the simultaneous production of a positive ion, is called ionization. In the process of ionization by collision, a free electron will collide with a neutral gas molecule, and it will result in the formation of a new electron and a positive ion. Now, if we consider from this figure, two electrodes, one is cathode represented by C and the other is anode represented by A, is placed, and in between them there is a gaseous medium. When high voltage is applied across these two electrodes, a low pressure gas column is placed in between these two parallel electrodes, and an electric field is applied across this. Then any electrode that starts at cathode will be accelerated more and more between collisions with other gas molecule during its travel to anode. So what is happening when high voltage is applied across these two electrodes? Electrons get released from the cathode, and this electron, due to the applied high voltage, will start to move towards the anode. When it is moving from cathode to anode, on the way it will make collision with various neutral gaseous atom and will result in the breakdown of these neutral gas atom into electron and a positive ion. Now, for this breakdown to happen, the energy gained during the travel between collision needs to exceed the ionization potential Vi. Now, what is ionization potential? Ionization potential is the energy required to dislodge an electron from its atomic shell. Okay, we know that electrons are held in its outermost shell firmly with the help of the nucleus of an atom. The bonding between them is due to their opposite charges. Now, to remove an electron from its atomic shell, it requires a minimum amount of energy. That minimum amount of energy is termed here as the ionization potential. If an energy greater than this ionization potential is applied to an atom, then the electron will get released from its atomic shell and the atom can be termed to be ionized into an electron and a positive ion. So the energy for this is obtained from where the electron that is traveling from cathode to anode, while traveling through this gaseous medium, it is having some kinetic energy. With this kinetic energy, it is hitting the neutral gaseous atom. So that kinetic energy has to be greater than the ionization potential. If that hitting energy is greater than the ionization potential of that neutral gas atom, it will result in its ionization and will break the neutral gas atom into an electron and a positive ion. This process is easily represented by the equation shown here. Here we have an electron, plus A indicates the neutral atom. When electron hits the neutral atom with an energy greater than its ionization potential, it will result into the formation of electron and a positive ion. So this was about the primary ionization that takes place by collision. Next is photoionization. Photoionization is a phenomenon which is associated with ionization by radiation, or photoionization involves interaction of radiation with matter. It can be any kind of radiation that is hitting the matter. Photoionization occurs when an amount of radiation energy is absorbed by an atom or molecule and it will exceed again its ionization potential. So whenever the electron needs to be released from an atom, that is, an atom needs to be ionized, the energy that is acquired by the atom, either in the form of collision or by photoionization, needs to be greater than the ionization potential Vi. In case of photoionization, the energy that the atom acquires is due to the energy of the incident radiation. The incident radiation will supply some amount of energy to the atom. So the energy that it is absorbing from the incident radiation has to be greater than the ionization potential. If it is greater than the ionization potential, by absorbing that energy, the atom will release its electron and will get ionized. There are several processes by which the radiations are being absorbed by atom. One is by excitation of atom to higher energy state. Whenever it is absorbing the energy, it is absorbing by the excitation by jumping into a higher energy state, or by direct excitation of atom due to continuous absorption, dissociation of diatomic molecules, direct ionization, etc. These are the various forms by which you can provide radiations to the atoms or molecules for absorption. In all the cases, the underlying concept is same. The energy that the atom is absorbing has to be greater than its ionization potential. If it is greater, the atom will break down into an electron and a positive ion, and the atom will get ionized. Similar to the equation that we can apply on the emission of radiation that occurs when electron jumps from higher energy state to the lower energy state, the similar equation can be applied for the condition of absorption also, because this is basically a reversible process, and the equation is represented as H into V, where H indicates your Planck's constant and V is the frequency of radiation plus A is your neutral atom. This will result into A star. A star indicates the ionized atom. Okay, so this is happening whenever an incident radiation falls on a neutral atom. Absorbing this energy, it will break down into ion, positive ion and an electron. Now for the ionization to occur, the condition that needs to be satisfied is this, that is lambda should be less than or equal to C multiplied by Planck's constant divided by Vi, where lambda indicates the wavelength of your incident radiation. So the wavelength of your incident radiation has to be either less or equal to product of velocity of light into ratio of your Planck's constant to the ionization energy of the atom. If this condition is satisfied, only then the ionization can take place according to this formula. So this was about the photoionization. These are the two basic ways from which primary ionization can occur in an atom. So primary ionization is basically a way in which electrons are initially released, and these electrons, which are called primary electrons, will keep on ionizing the neutral atoms that come in its way and will produce further electrons and keep on adding electrons and positive ions in the system and contribute to the flow of current in the system. Now we will see what is secondary ionization. The process of formation of secondary electrons following primary ionization is called secondary ionization. Secondary electrons are released by making ionization collisions and will produce additional electrons. The electrons will again produce ionization collisions and the process repeats. This is called secondary ionization. The discharge is self-sustained because once secondary electrons are formed, they take care of the situation. We don't have to interfere in it or control it. So it is called a self-sustained discharge also. What happens is whenever the primary ionization takes place, it will keep on releasing some electrons. The electrons that are released from the primary ionization will further ionize the other remaining neutral atoms and will produce few electrons. So the electrons that are produced by neutralization of gaseous atom by the primary electrons, that released electrons are termed as the secondary electrons, and these secondary electrons will further carry on the process of ionization by continuous collisions and production of additional electrons. And once it is initiated, it is non-stoppable. It will continue to produce electrons in the gaseous medium till the entire neutral atoms have turned into ions. So it is termed as self-sustained. Now for the secondary ionization to take place, how the primary electrons are going to produce the secondary electrons, that can take place by three ways. One is by electron emission due to positive ion impact, second is electron emission due to photons, and third is due to metastable and neutral atoms. Now how they work, we'll see. Secondary ionization by electron emission due to positive ion impact. Now we have said that when electron is released from the cathode, it hits a neutral atom and result into its ionization by forming an electron and a positive ion. This electron will move towards the anode, and on the way it will further neutralize other neutral gaseous atom and keep on producing additional electron, and the process continues. But what happens to the positive ion? As the electron is being attracted towards the anode, similarly the positive ion that is produced due to ionization will get attracted towards the cathode due to the negative charge. So as the electron is moving, similarly this positive ion will move towards the cathode. And this positive ion, when it will move towards the cathode, on reaching the cathode, it will hit the cathode and will transfer the kinetic energy that it was having and will result in the further emission of electrons. So when it will hit the cathode and transfer its kinetic energy, what is happening is two electrons are basically released. One electron will result into neutralization of this positive ion, and the second electron that will be released will further move and neutralize a neutral gaseous atom. So the electron which was released and was neutralizing your neutral gaseous atom, that electron is termed as the secondary electron, and it will continue the process of ionization, and that process of ionization will be termed as the secondary ionization. This is termed as secondary ionization because the electron that is released here was a consequence of the ion that was produced in our primary ionization. Now also, for this particular condition to happen, for the positive ion, when it hits the cathode, for electron to get released, the following condition has to be satisfied. What is the condition? The total energy of the positive ion, which will be equal to kinetic energy plus the ionization energy. This total energy of our positive ion needs to be greater than 2 times the work function. Work function is the function that is required to emit the electron from the cathode. It should be 2 times greater because 2 electrons are released here. So the total energy that the positive ion is having, it has to be greater than the 2 times the work function. If this condition is satisfied, in that case, 1 electron will be emitted and a second electron will neutralize this positive ion. Next, there is electron emission due to photons. For an electron to escape from metal, it should be given enough energy to overcome the surface barrier potential. This we know. The energy can be supplied in the form of photon of ultraviolet light of suitable frequency. Okay, whenever ultraviolet light of suitable frequency falls on the metal surface, its potential barrier or the ionization potential here we can say is overcome and electron gets released from the metal surface. Now, for the electron to get released from the metal surface, it needs to satisfy a condition, that is HV should be HV should be less than or equal to Xi. H is Planck's constant, V is velocity of light, and Xi is the work function of the metallic electron, that is work done to release the electron from the electron. And the frequency is given by the relation V is equal to Xi by H, where V is the threshold frequency. So if the incident radiation is having a greater frequency than the threshold frequency, the excess energy goes partly as kinetic energy of the emitted electron and partly to heat the surface of electron. Okay, so the underlying concept is for the electron to release from the cathode or the metallic electrode that we are using, the particular condition of H into V should be less than or equal to Xi has to be satisfied. If this condition is satisfied, then in this case the metallic electrode will release further electrons, and these electrons will result in the neutralization of the neutral gaseous atom in the medium. So this is the secondary ionization that will take place due to the photons. Next is the electron emission due to metastable and neutral atoms. Now, first of all, what is a metastable atom? A metastable atom is an overexcited particle which has more lifespan as compared to the lifespan of an ordinary atom. Okay, it is an excited particle. Electrons can be ejected from the metal surface by the impact of this excited atom, provided that their total energy is sufficient to overcome the work function. Okay, so whenever a metastable atom, metastable are the overexcited particle or overexcited form of an atom, when these overexcited atoms are hitting a metal surface, the impact with which they hit, if that impact is having an energy greater than the work function again the work or the amount of work that we need to do to remove an electron from that metal surface. If the impact of the metastable atom it is greater than the work function, then the electron will get released from the metal surface. This process is most easily observed with metastable atoms because the lifetime of other excited states is too short for them to reach the cathode and cause electron emission unless they originate very near to the cathode surface. Okay, so this method of electron emission is considered to be more frequently observed because we know that the work function has to be overcome. So other excited states, by the time they reach to the cathode, to hit the cathode and release electrons, the kinetic energy that it is having will keep on losing, and the energy with which it will hit will be less than sometimes the work function. But for metastable atoms, since they are not ordinary atoms, they are some overexcited state of an atom, mostly they only are capable to travel so long and have that much amount of kinetic energy that can be greater than the work function with which they can hit the cathode and will result in the release of electrons. Neutral atoms can also result in the electron emission. How? Neutral atoms in the ground state may also give rise to secondary electron emission if their kinetic energy is high equal to 1000 electron volt. At low energy, the yield is considerably less. So even neutral atoms, if the neutral atom due to some reason in the ground state is having a kinetic energy greater than 1000 electron volt, then even they can transfer this kinetic energy to the cathode and can result in the release of secondary electrons from the cathode, which will result in the secondary ionization process. So this was basically the concept of secondary ionization, where the electrons from the primary ionization have almost neutralized the gaseous atom, and the remaining neutral gaseous atoms were neutralized by the secondary ionization process. So a combination of our primary and secondary ionization has resulted in the complete breakdown of the gaseous medium and has converted an insulating medium into a conducting medium. So this was basically the concept of ionization in the dielectric materials, where an insulating dielectric material has been converted into a conducting form. So the points that we have discussed in this video was what is ionization, ionization in gaseous dielectrics, then concept of primary ionization, that is ionization by collision and photoionization, then concept of secondary ionization, which can be due to positive ion impact, due to photons, or due to metastable and neutral atoms. Hope you understood the topic. Thank you.